All right, hi everyone, and welcome back. Let's finish up this last problem. As always, I want to do a quick recap here, but a lot's going on, and so I just kind of hope you remember what we were just talking about from that previous video just a second ago. So here's what we've done. Area of a kite deals with the diagonals, diagonal 1 and diagonal 2. And when we draw these diagonals in here, originally I had a purple diagonal and an orange diagonal. When they're actually drawn in the kite, it splits the kite into 4 right triangles. And anytime you have 4 right triangles, you can do things like the Pythagorean theorem, which is a squared plus b squared equals c squared, or we can use sine, cosine, and tangent, which deals with, right, SOHCAHTOA, and the ratios we can set up from there. Really, you have to decide, what can you use and what can't you use. And every time you see a degree measure, so like an angle measure within the triangle that's not the 90-degree angle, sine, cosine, tangent is a great thought of using that skill for that problem. If you don't see a degree measure or an angle measure in there, then maybe we can do Pythagorean theorem. And so what I have highlighted, and I've redrawn this green triangle over here, is the fact that if we look at that green triangle, we know that the bottom side is 4. We don't know the right side and we don't know the slanted side. But because we know that angle in there is 40, we can figure them out. We just have to set up 2 different equations to do it. And so in orange, that's me solving for x here. I set up that the tangent of 40 equals x over 4, and then I solve for x. And then for y, that's what's happening down here in red. I did the same thing, but for y, it didn't deal with the tangent. It dealt with the cosine. And so I set up cosine of 40 was 4 over y, and I solved for y. And so what I want to do now is clean up some of this kite over here. And I want to show you, what we did and why we did it and what we have now, right? And so I'm going to kind of get rid of some of this color here. I'm going to leave other color, but get rid of some of it. Perfect. And so my x, right? X was over here in orange. That's this green x right here. And so I now know that that other part of the orange diagonal is 3.4. And so my purple diagonal had a side of 4 and another side of 4, making it 8 total. My orange diagonal, and I guess I can write it in orange, my orange diagonal has a part of 8 and a part of 3.4, so in total, that's 11.4. So by finding x out of that green triangle, I can now find the area of my kite because I know both full diagonals. One of them's 8, one of them's 11.4. So diagonal 1 times diagonal 2 divided by 2. Let's do that real quick, all right? So area is going to equal diagonal 1, I'll call that 8. Diagonal 2, I'll call 11.4. And then we'll divide that by 2. And when we multiply those together and divide by 2, we should get that the area of this triangle is roughly 45.4 meters squared. Excellent, excellent. Now, the reason why I solved for the area real quick before I talked about what was the purpose of y was because now I got to clean up this triangle. Or not this triangle, this kite, right? There's a lot of stuff going on. And so one thing I want you to see is this. Remember that our green triangle that we worked through was this triangle. And so the y was this single tick mark here, right? This y and that y, same thing. And so when I ultimately solve for y, which is down here, right, I found that it's 5.2, which means the side of this kite is 5.2. And remember, one tick mark and one tick mark match up, and so this side is 5.2 as well. Now, the reason I'm talking about y now is because y is helping us figure out the perimeter of the kite, right? I need to know all 4 outside sides of this kite, and then I add them together. Now I have 2 of them because I solved for y. And so the next piece I have to do, and then I can add all the sides together, is I have to figure out how long are these other 2 sides. Now they are going to be the same because they both have 2 tick marks in them, but I still need to figure it out. Once I figure out one, the other one will just be the same thing. And again, it's going to involve triangles. This time I'm going to highlight a different triangle, this one right here. And so I'm going to take that and I'm going to draw it all the way over here. And so the vertical part is 8. Vertical means up and down, right? The side to side part is 4. And our slanted side has our 2 tick marks in it. We don't know what that is. Now we do know that where these two sides meet need to be a 90-degree angle. If we're looking for this side, I can call it X, and I think you can get the picture here. We now have a right triangle. We know 2 sides. We don't know the third. If we look across from the 90-degree angle, we can call that side C, and we are going to do a squared plus b squared equals c squared. And so 8 squared plus 4 squared is going to give me what x squared is. And 8 squared plus 4 squared, 4 squared 16, 8 squared 64. So together that is 80. And then we'll take the square root of both sides. And it's going to tell us that x is going to equal roughly 8.9. Now remember that x that we just found is the 2 tick mark side. So I know that this is 8.9. And because it has 2 tick marks in it, and so does this side right here, this side's 8.9 as well. So now I can find my perimeter. And I'm just going to find space. I'll do it up here. Perimeter equals the 5.2 plus the other 5.2 plus 8.9 plus the other 8.9, right? And so when we add a couple of 5.2s together and a couple 8.9s together, we will get that our perimeter is 28.3 meters. And there's your perimeter. Here's your area. And it is quite the process. And I think that's very clear after, walking through this example, that it's a lot going on, right? And so again, just to reiterate kind of what I talked about at the beginning of our Unit 8 videos, finding area makes sense, right? Finding heights, finding bases, plugging them into formulas, all of that, I think you guys are great at. The issue with this unit, as is the issue with geometry as a whole a lot, is that as we learn old skills, we cannot forget them moving forward. You can see that tons of stuff that we introduced in Unit 6 gets brought up in each and every single area problem. And so that's really where the challenge lies here. Can we remember those old skills, and can we visualize these problems appropriately so we can apply those old skills in the correct ways? I believe in you guys, and I think you're doing a great job. If you need more guidance, please join my Google Hangouts. Please email me. Please ask for some help, and I will absolutely do my best every single time to help you with what you need. So thank you very much for your hard work. Keep it up. Let's move on to the part 3 worksheet. All right. Have a great day.